Ladies and gentlemen, this is the last lecture of the Measure Phase module of Lean Six Sigma. During the lecture, the following topic will be covered: value stream mapping using iGraphX and Minitab. To create a value stream mapping in iGraphX, on the File menu, point to New, then browse the Value Stream Map category, choose Lean Value Stream Map, and click Create. In the Shape Palettes window, browse the Value Stream Map Standard and all shape palettes. Value Stream Map Properties dialog box consists of Lean Timeline, Setup tab, and Graph tab. Available for the active timeline from the Lean menu, or when you right-click on a Lean diagram by choosing Value Stream Map Properties. You may also double-click a Properties Summary, Customer Demand block. These are diagram-level Lean properties for a specific timeline. First important property is the available work time, which sets the production schedule for the map. Also, hours per shift can be partial hours. Click the Use Custom option if you want to use a custom setup for available work time. The second important property is the takt time, which sets the rate of production required to meet customer demand given available work time. The other factors automatically recalculate when you change customer demand or the time needed to produce each piece, or takt time. Customer demand is the number of pieces produced per unit of time. Takt time is the rate of production required to meet customer demand given available work time. Takt time units are customizable by milliseconds, seconds, minutes, hours, days, weeks, months, or even years per piece. Takt goal displays a percentage, or time-based takt goal line, on the work balancing graph. The takt goal line is an optional visual indicator that aids interpretation of takt time data. Another property is the inventory lead time. Inventory is a non-value add, NVA, and should be eliminated, or at least minimized. Inventory lead time is calculated based on takt time, uses inventory amount, and takt time to calculate is the following: inventory amount, multiplied by takt time, divided by available time per workday. Based on activity capacity, uses inventory amount, and the next activity's capacity to calculate is the following: inventory amount, divided by capacity, using the capacity of the step following the inventory step. For the shape properties data, some shape data elements are entered, some are calculated, and some entered data elements are calculated by relationship to other data elements. For example, if you enter processing time, it is assumed to be all value-add time. However, if you also enter non-value-added time, value-add time will be calculated for you. If a certain data elements, such as NVA or VA, that total greater than the total cycle time, a data entry warning appears to alert you to the discrepancy. The value in parentheses shows the correct or implied value. Now, all important data have been entered. Some Lean data is calculated, indicated by gray background, or read-only fields, in the Properties dialog box. In addition, accumulated values display in gray text. Lean data block appears below the process step in the Lean map. The operator's value displays directly on the process step with an icon. A timeline displays value-added time, VA, which is the time a customer is willing to pay for, and lead time, LT, the amount of time it takes a piece to move through the process, using Lean data elements built into the diagram. Click a shape in the Toolbox toolbar on the left side of the application window. Then, with your cursor inside the Start shape in the diagram, press and hold your mouse button, click and drag to the desired location and release the mouse button to drop the shape into place, with an automatic connector from the Start shape. If a toolbar or a window is hidden, use the View menu to find it, and show it in the application window. You can also place a shape from the Shape Palettes window, by default, on the right side of the application window, in the same manner. Add inventory between two processes is represented by these icons. If you need to include an inventory count, add it below the triangle icon. This symbol can also represent stored inventory. For example, lead time is equal to 225 seconds. Adding more WIP, increasing the lead time. Now, lead time is equal to 80,855 seconds, which is equal to 22.45 hours, which is equal to 2.8 days. In the Shape Palettes window, click the supermarket shape and drop it between two process steps. Use the Kanban flow from the line library to create the withdrawal and production Kanban flows. Drop the Kanban production or withdrawal graphics from the VSM standard palette in the Shape Palettes window onto the Kanban flow lines. To add the outside sources, first, draw customer, supplier, and production control icons. Then, draw outbound shipping icon and truck with delivery frequency. Finally, draw inbound shipping icon, truck and frequency. The map after adding the outside sources. Add supplier connector and receiving inventory data. The truck icon represents external shipment to customers or from suppliers. Please note that the lead time now is equal to 54.5 hours, which is equal to 196,200 seconds. Add customer connector and shipping inventory data. Please note that the lead time has been increased to 86.5 hours, which is equal to 311,400 seconds. Add communication lines. In the Toolbox toolbar, select a connector line tool, such as electronic information flow or manual information flow. Follow the steps to create material flow. To add more properties to the value stream map, on the Tools menu, choose Set up Custom Data. This dialog box contains slightly different controls for Lean Value Stream Map Data Setup. You can customize the properties for all map data, like cycle time, value add, non-value add, defect, operators, inventory, distance, transport, and so on. The work balancing graph displays a graph of takt time of the process in relation to production time at each activity or step. The graph automatically updates when changes are made to the value stream map data. Production time at a step is the time between each piece being produced. Work balance chart is helpful because, using the graph, you can identify the bottleneck processes, which is the operation with the longest cycle time. Parameters to be considered in the construction of value stream map. Identify lot size and setup reduction. Reduce WIP. Cycle time reduction. Eliminate, or at least reduce defects. Increase availability. Combined operations. To construct value stream map in Many-tab. Open Many-tab workspace. Click New, then choose a value stream map tool from the list of popular tools. In the Insert Tool dialog box, click a value stream map template, and then click Create. When you open a blank map, then start by adding shapes and connectors. In the Shapes gallery, click a shape, and then click a workspace. To connect the shapes, click Connector, and then choose a connector. To ensure that shapes stay connected even when you move them, connect the shapes at their anchor points. Anchor points turn green when they are connected to the shape. To enter process data, right-click a process shape, choose Shape Data, then add Shape Data, and then enter values for the data on the Process tab. To enter inventory data, right-click in Inventory Shape, choose Shape Data, then Add Shape Data, and then enter values for the data on the Inventory tab. Inventory shapes include inventory, buffer stock, supermarket, and FIFO sequence flow. In order to calculate the takt time, enter the customer demand, which is the number of product units or service units that customer requires in a certain period of time. Minitab Workspace uses the following equation to calculate total production time available. The total production time available is the total time of a shift, minus the total time for lunch breaks, meetings, and so on. The cycle time required to match the pace of the customer demand. Minitab Workspace uses the customer demand and the total production time available to calculate takt time. The cycle time of a process step is the time from one completed output to the next completed output. In Minitab Workspace, when you enter cycle time values in the process task pane, they appear in the troughs of the timeline. Typically, you enter cycle time, or value-added cycle time, and non-value-added cycle time. If you enter all three values, Minitab Workspace will display either cycle time, or the sum of value-added cycle time, and non-value-added cycle time, whichever value is greater, on the top of the trough. Please note that value-added cycle time is always displayed on the bottom of the trough. When you enter inventory on an inventory shape on the timeline, Minitab Workspace automatically calculates in process inventory time using takt time, or the cycle time of the next process step. On the Map tab in the Task pane, you can choose whether to use takt time or cycle time in the calculated inventory time equation. Raw materials inventory is inventory that is ready to be processed. It is located before the first trough on the timeline. Finished goods inventory is product that is ready to be shipped to customers. Finished goods inventory can be located after the rightmost process shape on the timeline. The timeline summary box appears after the last process shape on the timeline and shows the following calculations. Total cycle time, the sum of all cycle time values displayed on the timeline. Total value added CT, the sum of all the value added cycle time, which are displayed on the timeline. Total non-value added CT, total cycle time, minus total value added cycle time, which are displayed on the timeline. Lead time, the sum of all inventory time and cycle time values, which are also displayed on the timeline. Please perform the first activity and send your outputs by email for assessment. Please perform the second activity and send your outputs by email for assessment. Please download from the resources the instructional video for value stream mapping using Excel templates, Sigma Excel, iGraphs, and Minitab. Measure phase Sigma Excel.mp4. Value stream mapping iGraphX.mp4. Value stream mapping, Minitab.mp4. Measure phase templates.mp4. Now, we will perform checklist for the measure phase. In case of any unmarked point from your point of view, please replay the lectures of measure phase, check the course materials, watch the instructional videos, check the templates and perform the activities. We will perform the checklist for the following measurements. The most important output measurements are identified. Every critical customer and business requirement is measurable through at least one measurement. Data collection. The data collection plan is drawn up. The necessary strategy for collecting data, scope and method, is determined. Measurement system analysis. The data quality is secured, for example through a gauge R&R. Evaluating data. The data is depicted visually and interpreted. Performance indicators. The current and relevant key performance indicators, DPMO, ppm, DPU, yield, CP, CPK, and process sigma, are calculated and interpreted. For the process steps have been analyzed, defined, and measured accurately. Time to develop your project. Collect data. Design sheets. Apply assembling techniques. Apply Pareto analysis. Calculate process capability and sigma levels. Check measurement tools. Design value stream map for current situation and target future situation. Thank you, and see you in the first lecture of Analyze phase.